chapter 4 review. So the top two, we're forced to do the 3 steps. These are not on our unit circle. They're blatantly, obviously not on our unit circle, right? That one we could do straight up tan. This one we could do cos of 1 over that, and then we did the 3 steps. Reference angle, cast rule, get our answers, find the coterminals, right? These ones, say sine theta, we have to solve for theta for these ones, but these ones are actually on our unit circle. So we can go to our unit circle and pull them off, find the coterminals. If you don't spot that though, we can still do the 3 steps, right? We can do reference angle, cast rule, get our answers. So the 3-step rule when solving always works. It's just longer if you don't spot it. So this one is where sine is negative root 3 over 2. Sine is at root 3 over 2 at 60-degree reference angles, or pi over 3s. And sine is negative where y is negative, which is here and here. And you could just find them off your unit circle. They're at, if you want to do actual degrees, they're going to be at 240 and 300. Did everyone get that? Hope so. And then we can look at our radians. It's from 0 to 4 pi. 4 pi is 720 degrees, because 2 pi is 360. 4 pi is 720. So these fit between 0 and 720. True. But there's also more answers. So I have to find their coterminals. So if I add my 360, I get 600. If I add my 360 to this one, I get 660. Do both of those fit? Yes. So I actually have 4 answers. Their theta equals 240, 300, 600, 660, which are all lovely answers. But if I did this, I'd be getting, like, I don't even know what they give me. They give me some marks because I'm showing stuff. But my question is in radians, right? So I have to make sure my answers are in radians. So 240 in radians is 5 pi over 3. And then is it 7 pi over 3? That doesn't sound right. Oh, 5 pi over 3 is 300. Good call. 4 pi over 3, 5 pi over 3. What's 600? 10 pi over 3? I heard 10,000 at one point, and I'm like, no, I don't think that's right. But you said 10 pi. Okay, cosecant. The moment I get cosecant, secant, or cotan, and I get an answer, I can flip answers. I cannot flip angles. Is 2 an answer or an angle? An answer. So our answers in radians or degrees? Everyone asks me that. Neither. It's an answer. Answers are in neither radians nor degrees. This puppy right here is in radians or degrees. That's just a length of measurement. That's just like a distance, right? So 2 is in neither radians or degrees. It's just an answer. So I can go, his best friend is sine. Sine theta equals 2 is over 1. So this is 1 over 2, which is why it's in this question on this review sheet, because a half is on my unit circle, right? Sine equals a half at 30-degree reference angles. Sine equals positive a half when y is positive, so it's here and here. And this is from negative 360 to 360. So this one's 30 and 150. Could I go pi over 6 and 5 pi over 6 and then just subtract 2 pi's and use radians? Yeah, that'd be the best way to go about it, actually. But if radians scare you off, can you do the degrees, figure it out, convert? Sure. So 30 and 150 fit because they fit between the 0 and 360 part. Now I need to check for the 0 to negative 360 part, so I need to subtract 360 from them to get their coterminals that fit. When I do 150 minus 360, I get negative 210, which fits. And when I do 30 minus 360, I get negative 330, which fits. 30 is pi over 6. 150 is 5 pi over 6. 210 is 7 pi over 6, so negative 7 pi over 6. And negative 330 is negative 11 pi over 6. Okay? So there's two solvings that you could get. You could get a solve where it's blatantly not on the unit circle, 3 steps. Solve where it's on the unit circle. You could do the 3 steps you want, or you can spot it on your unit circle and then find its coterminals, right? Then there's this one. I told you you have to be able to spot this type of question. It'll say, determine the value of the 5 other trig ratios. It wants other trig ratios, or it could just ask for one. It could ask for like cotan or tan or whatever it may be. They give you a trig ratio, and then they give you another part to narrow that arrow down, right? Because you're going to get 2 arrows from the trig ratio. So here, they give me a trig ratio, which is cosecant. They gave me the answer. Cosecant, I could go sine, if I want to, is 3 over 5. I could absolutely do that. It's sine your resume. So they gave me y and r. So when I'm given a trig ratio, and I'm given another piece of information, remember my steps are to draw a triangle. So you draw your 2 arms. So I need where sine is positive. Sine is positive here and here. Then they have to give me another piece of information, or I won't know if my x is positive or negative, right? Which they might not actually give me another piece of information. And I'm going to get, instead of 5 trig ratios, I'm going to get 10. Because I'm going to get negative x's and positive x's. So they gave me tan is less than 0. Less than 0 is a fancy way for them to say negative on your diploma or on my unit tests. So tan is negative. Well, tan's not negative here, so I'm going to draw the triangle here, which means my x is going to be negative, right? My y is a 3. My r is a 5. How do I get that x? Pythagorean theorem. So I'm going to go x squared equals 5 squared minus 3 squared. X squared equals 25 minus 9. X squared equals 16. Plus or minus x equals plus or minus 4. And we know because we drew it, it's actually negative 4. Then I need my other trig ratio. So I have cosecant is the one they gave me. Sine I already have. Sine theta is just the cosecant flipped. Cos is cook extra rice. So extra is negative 4. Rice is 5. Its best friend is secant, which is rice extra, so it just flips. Or I could write that as negative 5 over 4. It'd be fine. Tan is tan your x box because we want it to get its vitamin D. And then cotan is negative 4 over 3. Okay? Make sense? So there's that one, and then we flip over. We have one last page. So here, we still have first degree trigonometric equations. We're still solving them, but I didn't just give you like sine equals something, tan equals something, cotan equals something. You got to get to that, right? And remember, when they look overwhelming like this, I told you maybe you might want to maybe change them to m's. Okay? So we're going to go let m equal cos x. So I'm going to go 7m plus 5 equals 2 minus 3m. I'm going to add the 3m over. And I get 10m plus 5 equals 2. Subtract 5. 10m equals negative 5. Divide by 10. Negative 3. Divide by 10, and I get m equals negative 3 over 10. And then I go back to, okay, cos x equals negative 3 over 10. So I'm solving for x or for theta. If my answer is off the unit circle, I do the unit circle. If my answer is not off the unit circle, I have to do 3 steps. Reference angle, cast rule, get answers, right? Every single time. So my reference x equals cos neg 1 of 3 over 10, because I always use the positive for my reference. What mode do I want to be in? Well, I can be in radians if I want, but often I just do degrees. So I go second cos 3 divided by 10 and I get 72.5423, etc. degrees. Second step, cast. I need cos negative. And this is my reference angle. So we're going to do 180 minus that answer. And we get 107.4576031 degrees. And then I go 180 plus it. So I get 252.54239688 degrees. So those are my two answers on 0 to 360, right? What the heck was our domain? Our domain between 0 and 360. Boom. X equals 107.5 degrees and 252.5 degrees. Yeah.
You didn't keep the decimal.
I would have to specify. Yeah. If I didn't specify, if you rounded like 107 to like 110, yeah, you'd be wrong. But any other rounding variation, you're fine. If you're going to have to convert those decimals to radians, though, keep as many as possible. So here I have cotan. It's by itself, so I can isolate it pretty easily. I'm going to subtract 17. If you want to make it an m, go ahead. 3 cotan x equals 12 divided by 3. Cotan x equals 4, which means tan x equals a quarter. Because I can flip answers, I can't flip angles. Right? No flip answers. Because answers aren't in radians or degrees. Right? If an angle, if it's cotan of 30 and you want it to be tan, you have to do 1 over tan of 30. Remember, you go to your formula sheet, pull that formula off. So we have to do our reference angle. Reference x equals tan neg 1 of a quarter of 0.25. And I get 14.03624347 degrees. Step 2, cast rule. Tan is positive. Tan is positive here and here. That's 14. That's about 14, right? Great thing is, if it's in the first, then it's actually a reference angle. This one's going to be 180 plus 14 point blah, blah, blah. So it's 194.03624347. So we got our degrees between 0 and 360, right? Which is lovely. They want it in general form. I'm just going to show you what the heck that means. Okay? General form means every single angle gets accepted. General form is not going to be on your unit test, just so you know, but it will be on your chapter 6 one. It's a trig 2. I'm just going to show it to you here. General form means I'm not giving you a restricted domain. The domain is XCR. So I want every single answer that's possible. Remember when we do general form, it's always whatever the degree is or radian is plus, and then if it was just normal, it was 2 pi n NEI. That was how we got our coterminals, or plus 360, because coterminals happen every 360. We agree? What we could do here is we could actually do both of these separately. If I do 14 and I add 360 to it, I'm going to keep landing on every single coterminal angle that's going to land on there, right? And if I go NEI, I'm counting all the integers, so I'm counting all the negative ones as well. So I could do these as separate. I can go x equals 14.04, I'm going to say degrees, plus 360 degrees n, means I'm counting every single 360, and NEI means I'm counting every single 360 from 0, 1, 2, 3, negative 1, negative 2, negative 3, all of them, right? Because I'm not restricting here. I'm doing every coterminal, right? And when I do every coterminal, I go 360 n NEI. Then I can do my other one, which is 194.04 plus 360 degrees and NEI. Yeah, So that happened. And then, I've been so good, and then October came, and I've just been falling apart. Okay, so we can split these up, because remember grade 10 taught us we can split them up if one of them is a perfect square. Square root of 1 is a perfect square, so we can go 1 over root 2. 1 over root 2, we have to think in our heads, that's something that's off of our unit circle. It's the unrationalized form of what? Root 2 over 2. This is the exact same as saying plus or minus root 2 over 2, correct? Because I can multiply by root 2 over 2, root 2 and root 2. So I actually have sine x equals plus or minus root 2 over 2. So you have to remember to take the actual plus or minus signs because you're going to get it in every quadrant now. I actually have a solution here at this 45, this 45, this 45, this 45. Every single quadrant I have an answer because CAST, this is where sine is positive in quadrant 1 and 2 and negative in quadrant 3 and 4, and it's plus or minus, right? So I'm going to get 45, 135, 225, 315, or their radian measures pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Right? So I'm going to get 4 solutions between 0 and 360, or 0 and 2 pi. They want me between negative pi and pi, right? So negative pi and pi is negative 180 and 180. Well, these are between 180. These are too much, right? So if I take their coterminals, they'll actually be just right. If I take these two coterminals, they're going to be too much because they're going to be bigger than negative 180. So if I go 225 minus 360, I'm going to get negative 135, which is negative 3 pi over 4, and that one fits. If I go 315 minus 360, I get negative 45, which is negative pi over 4, which fits. So this one will fit, this one will fit, and so do these two. I should have taken the radians, sorry, these two. So my variable is x. So x equals pi over 4, 3 pi over 4, negative 3 pi over 4, and negative pi over 4. So this one I could just go blatantly solve because I didn't have an x in it. I just had a sine x and I could get it by itself, right? Even though I did have an m squared at one point, it didn't come with an m, so I didn't have to get to one side and set equal to 0. Yeah?
So in the case you just write positive and negative.
Yep. Totally good. You write plus or minus both of them, and you cover it. Yeah. 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 All right. So this one, we have tan squared and a tan. So I'm going to let m equal tan theta. So I'm going to get m squared minus 4m. Oh, I have an m squared and an m. And I have equals negative 3. So I have to move that 3 over and set it equal to 0. And then I'm going to factor it. What times what equals 3? What plus what equals negative 4? I'm going to get negative 3, negative 1. Second guessing my brain for some reason. Do I have to do decomp for this one, or can I just go right to brackets? I'm going to go right to brackets because I have a what in front of my m squared? Positive 1. If it's a negative 1, I have to decomp. Or I have to move it all to the other side and set it equal to 0. Then I can just go to brackets. So I'm going to get m minus 3, m minus 1 equals 0. And then I get m minus 3 equals 0. M minus 1 equals 0. M equals 3. N equals 1. And I get tan theta equals 3. Tan theta equals 1. Some people will say, well, tan theta can't equal 3. I max out at 1 and negative 1. Nope, that's not true. Sine and cos graphs max out at 1 and negative 1. Those are the only ones. Like if you get sine x of 2, you can't do it. Sine x equals 2, or sine x equals negative 2. Sine and cos themselves, basically, max out at 1 and negative 1, right? But tan graphs, which we're going to actually look at, not today though, They go on for infinity and negative infinity. So tans can equal whatever. It's just sine and coses that max out at 1 and negative 1. So, reference angle. Reference theta equals tan neg 1 of 3. So I get 71.5650518 degrees. 2. Casserole. Tan is positive here and here. So this is this one. This one's going to be 180 plus it. So I get 251.5650518. Which both of those land between 0 and 2 pi, correct? They just happen to be the degree version. How do I go from degrees to radians? Pi on times pi over 180. Because Dr. Pot. Degrees to radians, pi on top. So I have to multiply this by pi over 180. Literally the whole thing, not just 180. Pi, and then divide by 180 and get an answer. Multiply by pi and 180 and get an answer. So this one is 1.2 radians or rads, or I don't have to write anything. So I'm going to write rads so I know it's a radian measure. Yeah.
Keep it as a fraction.
You don't want to because it's going to be 71.56 divided by 180 with a pi. Right? Like it's going to be that you have to write that whole decimal over 180. You only keep it as a fraction if the decimal for degrees, or sorry, if the degrees are not a decimal, which the next one won't be. And then this one's 251 times pi divided by 180. I get 4.4 rads. So these ones I literally put the pi in because the degrees is an ugly decimal. When I go to do reference of tan of 1, that one, it's 45. So that's a nice one. Tan is positive here and here. So I'm going to get 45 and 225. Now those ones I'm going to keep as fractions because they're nice terminating decimals. So I multiply by them by pi over 180, or I look up my unit circle. It's pi over 4. This one's 5 pi over 4. So I go look at what my variable was. My variable was theta. So theta equals, I don't know what I'm doing, is way out of order. 5 pi over 4, pi over 4. Just randomly picking them. 4.4 and 1.2. So if the decimal is a nice whole decimal, then you can leave it as a fraction. The error lies where the answer is 5 pi over 4 and it's a numeric response. And people will go, okay, 5 divided by 4, 1.25 pi. And they're like, okay, I'm going to put in the numeric response. And they put in the numeric response as 1.25. But there's no pi in it, is there? So if that's the case, if they want 5 pi over 4 to the nearest decimal, you're going to go 5 times pi divided by 4, and it's 3.92. Okay, 3.9. So if they want your radians in a numeric response to the nearest tenth, you put the pi in. 5 pi divided by 4, give it to me. Unless they say a pi over b, or it's ab. They'll sometimes do that, and then your answer will be 5, 4. Or they'll say a times b, or a plus b, or a, b, respectively, and respectively means in that order. Right? So it just depends on how they ask it, 'cause they can ask it any way they want. Yeah.
Is this review, is this pretty
Yeah. That's chapter 4. Chapter 5 is what we're doing now. That's on it as well, the graphing. Graphing of sine functions. Yeah. 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 That's all they hear in podcasts. Whenever you hear, yeah, someone's going to the bathroom. That's what's happening. Or getting a drink. Or possibly wandering. I don't know. These are all options. They're leaving the room. Okay, I'm going to hand a handout out. I've said to you before that the cos and sine graphs are literally just a 90-degree shift from each other, right? If I took each one of them and I shifted them left 90 or right 90, they would be the exact same graph, wouldn't they? Because the amplitudes are the same, they're from -1 to 1. The periods are the same, they repeat themselves every 360 or 2 pi. The midlines are the same, the midline's the middle line that cuts the graph in half. Remember that d value. So all that stays the same. The only thing that's different is the phase shift, the c. So we're going to go through A, B, C, and D, and we're literally going to find the equations, 4 equations for each of them. A positive sign, a negative sign, a positive cos, and a negative cos. It's going to be a blast. You're welcome. Okay, so the first thing we're going to do is we're actually going to find the amplitude of each of them. We're going to find the amplitude of each, the period of each, and the d value, the midline of each, because that doesn't change on any of the 4 equations we're going to come up with. So the amplitude of a graph, we can count literally from min to max and divide by 2. We can go, how far is it from minimum to maximum? So 1, 2, 3, 4, 5, 6. It's 6 divided by 2. My amplitude is 3. It's half the distance from min to max. Or we could have used the formula, which I told you write down, absolute value of max minus min divided by 2. That will also get you 3. Okay, so you can use the formula, or you can count from min to max, and then that distance divided by 2. Okay, so the amplitude for the first one is 3. What's the amplitude for B? How far is it from minimum to maximum? 1, 2, 3, 4. It's a distance of 4, right? So my amplitude is going to be 4 divided by 2, which is 2. What's the amplitude for C? What's my vertical distance from min to max? 1, 2, 3, 4. So my amplitude is 4 divided by 2, which is 2. And then my amplitude of the last one? What's the vertical distance of the last one? 6 from min to max divided by 2, so it's a 3. Our amplitude gives us is what on our equation? We did this yesterday and the day before. C, yeah. It's a vertical stretch. It's the A value, right? Our amplitude is the absolute value of our A value, correct? So our A value then, if our amplitude is 3, our A value could actually be -3 or +3, correct? This is why we get 4 equations. So let's have some fun here. Your equations can be in this form. There should be brackets here as well. On your formula sheet at the very bottom, it shows them to you. A sine square bracket B x minus c plus d y equals a cos square bracket b x sets these two down here, right? So we're actually going to do 4 equations. We're going to do our A then is plus or minus 3 for this one, positive or negative. So we're going to go y equals 3 sine. Y equals -3 sine. Y equals 3 cos. Y equals -3 cos. Did I find my A differently for any of these 4? Nope. Same thing. It's just based off my amplitude. We agree? Okay. What's my A for B possibly? My A could equal positive or negative what? 2. So here I go again. Y equals 2 sine. Y equals -2 sine. Y equals 2 cos. Y equals -2 cos. So these ones, my amplitude is 2. So my A value is plus or minus 2. So I'm going to get y equals 2 sine. Y equals -2 sine. Y equals 2 cos. Y equals -2 cos. And then my amplitude here, so A is going to equal plus or minus 3. Why am I putting not equal to? That's rationals from grade 11, from 3-2. My brain just went back to period 3. A equals plus or minus 3. So Y equals 3 cos, 3 sine. Y equals negative 3 sine. Y equals 3 cos. Y equals negative 3 cos. Right, so nothing crazy. The next letter we have to find is B. How do I get B from the period? Is B the period? No, B is the period. It doesn't actually exist. B is the period. You can't find it off of a graph. But you can use the period to get it, right? So our formula for the period depends on what your x-axis is in, if it's in radians or degrees. The period formula is 360 degrees divided by B, correct? Well, I can actually swap these out. I can bring the B up by multiplication and the P down. So I can do B equals 360 degrees divided by the period. So if I know the period, I can get B. Or B equals 2 pi over the period, depending on if the x-axis is in radians or degrees. So this x-axis is in degrees, correct? Remember I told you you can get a period from min to min, max to max, min to max times 2. Start at the y-axis until you keep going until you repeat yourself, right? So if I start here, I'm going to go past the max, back down to here. When did this one repeat itself? 180, right? So I know the period equals 180. So B equals 360 divided by the period, which is 2. Does that make sense? If my B is 2? If my B is 2, what stretch factor is that? Horizontal stretch by a factor of? 1/2. So if the period's 360, it's now 180. Is it 180? Yeah. So I'm good. Remember, your horizontal stretch always flips. Always. There's never a choice. There's never a chance when it doesn't flip. Always flips. So if your B is 2, it's a horizontal stretch by a factor of 1/2, which takes my 360 to 180. Makes sense. So it's good. I'm going to go like this. 2, 2, 2. Did I use any brain matter after I found the 2? Nope. Follows all the way down. Right? Then I'm going to go X, and I'm finding my C last because it's the only thing that's different on all of them. So my C I find last because it's the only thing that's different on all the equations. What's the period of this graph? I can start at the Y. I can go from max to max, 135 plus 45, 225. Or I can go, I'm going to go past the max, past the min, back up to that same height. When did it repeat itself? Horizontally, from 0 to 180. So how long did it take to repeat itself? 180. So if the period's 180, my B is 2 again. I'm going to prove why. 360 divided by 180. My B is 2, which means I stretched it by 1/2. I'm shrinking it, right? My B is 2. It's a multiplication of 1/2. I'm actually going to have 2s for these ones as well. I'm going to make you do C and D, but what's the catch with C and D? What's my axis in? Radians. So what am I going to do? I'm going to do B equals 2 pi divided by P, right? 2 pi divided by P. So you try getting B for C and D. The last thing we're going to look at is D, the midline, and you have to draw the midline. So when you go to write out equations, you're going to have to draw the midline, and you'll see why when we go to do signs. So the midline is where the amplitude should meet. So if my amplitude is 3, I should be able to count down 3, count up 3, and my midline should be where they meet. So you can do it this way. I'd say my midline is at y equals 1. Well, my d's are all 1s. You're like, I like formulas. I don't like finding stuff myself. The D formula is max plus min divided by 2. So you could just go 4 plus negative 2 divided by 2, which is 2 divided by 2, which is 1. So you could physically use that formula, max plus min divided by 2, and do it that way, instead of counting down your amplitude, up your amplitude. Totally fine. Both get you the same answer. Whatever works for you. Okay? So here, I'm going to count down my amplitude of 2. I'm going to count up my amplitude of 2. And this one has a midline at y equals negative 1. So now I'm going to have minus 1, minus 1, minus 1, minus 1. Once again, if you like the formula, you could go D equals max, which is 1, plus min, which is negative 3, divided by 2, which is negative 2, divided by 2, which is negative 1. Same total answer. Do I care which one you use? Nope, as long as you get it right. The next one, my amplitude is 2, so I'm going to count down 2, count up 2, and I'm going to meet again at y equals negative 1. The B for this one, B equals 2 pi divided by the period. The period of this one, if I start here, I go up past the max, past the min, it's pi. 2 pi divided by pi is 2. 2 again. The period of this one, if I start at the y-axis at this height, I go past the max, past the min, back up to that height, 4 pi. So B would equal 2 pi divided by 4 pi, which is a half. So my B is a half. Does that make sense that it becomes 4 pi, that my B is a half, when it was 2 pi? Yep, and then multiplying by what? 2. Horizontal stretch by factor 2. And then my D value, I go up 3 and down 3, so I come down 1, 2, 3, up 3, 1, 2, 3. My midline for this one's at y equals 1. Now, can you do me a favor for later? You're going to go to your y-axis, and you're going to go to your closest intersections with your midline in the graph, and you're going to bold them. So watch this. I'm going to use bright yellow. Okay, so I go to my y-axis, and this is my closest intersection, and so is this. You see what I'm doing? I go to my y-axis and I'm picking where my midline intersects with my graph. I'm going to bold them. I go to this midline. Here's my closest, here's my y, my closest intersection. This one's actually on the y, and then these would be my other two. I go to this one. Here's my y-axis. My closest intersections are here and here. The midline. I go to this one. Here's my green at the midline. This is my closest intersection, and so is this. You see how I picked my closest intersections and I just bolded them? You're going to do that before you make any decisions about C values. Okay? Now, don't go to your calculator, you're just paying attention. So if I go, I'm going to go mode. 3, zoom, trig, sine, cos x. I'm doing coses. Oops. Cos x. We're going to look at coses first, because coses are the easy ones to find the C's for. go graph. You don't have to do anything. What's on the y-axis right now for a coast graph? What's on the y-axis? Is it maximum on the on the y-axis? Yeah. So for coast graphs, I actually have a maximum on here. Correct? Now, it's at 1, 0, or 0, 1, I mean, right? So if I throw a horizontal stretch on that, is it going to change my point? That's 0, 1. If I throw a vertical stretch on it, is it going to take my max off? If I throw a vertical stretch, will it take my max off? No. Will it change the number? Sure, but will my maximum move off of it? Nope. If I multiply by negatives, maybe. But the only thing that's actually, if I move it up, if I move this up at all, does it still make my maximum stay on it? Yep. If I move it down, does it make my maximum stay on it? Yeah. The only way I can get maximum off on a positive coast is if I horizontally shift it. That's it. If I horizontally shift my positive coast graph, that's the only way I can get the maximum off of the y-axis. Okay? So, we're going to do all positive coast C values right now. So I'm going to look at the first graph. Is my maximum on the y-axis? Nope. I have a maximum here and a maximum here. So how far did they move off the y-axis? I either can say I moved 90 to the right or I moved 90 to the left. Which one's better? The one that matches the multiple choice answer. That's the one that's better because both of them are accurate. So remember, if it's on the right, I moved it to the right because it used to be on the y-axis. If it's on the left, I moved it to the left. So I'm going to go to my positive coast because positive the maximum's on. And I'm going to go minus 90 to represent the moving 90 to the right. Could I have went x plus 90 and moved 90 to the left? Yep, would have worked just fine. We're doing all positive coasts right now, all at once. So we go to B. Okay, I'm going to look for my closest maximum. Is my maximum on the y-axis? Nope, it's been moved what? 45 to the what? To the right. So my positive coast is going to be x minus 45 degrees. Because it's moved 45 to the right. Go to my next one. Closest maximums. Well, pi over 2 to the right or pi over 2 to the left are both equally as far, right? So I could go x minus pi over 2 and represent it to the right, or I could have went x plus pi over 2 and said it moved to the left. Some people will say to me, what if both answers are on multiple choice? They can't be. They're both right. So they'd have to pick one or the other. This one, I look for my closest maximum. Where's my closest maximum now? It's right here. Well, what the heck is that? It's 3 pi over 2. If you don't know, the way you can figure out the scale of the x-axis when it's in radians is you can count how many ticks it takes you to get to pi. So how many ticks did it take me to get to this pi? 2. So this one would be pi divided by 2. This, and then we just keep going. 1 pi divided by 2. Then this would be 2 pi divided by 2, which reduces to pi. This would be 3 pi divided by 2. This would be 4 pi divided by 2, which reduces to 2 pi. This would be 5 pi divided by 2. This would be 6 pi divided by 2, which is 3 pi. This is 7 pi divided. I could just keep going on for life, right? So where's this one happening at? 3 pi over 2 to the right. So I'm going to go minus 3 pi over 2. With a negative cos, so I have a negative in front, where does my reflection happen when I have a negative in front? Reflects in the x-axis. So let's watch. So with negative coses, what's on my y-axis? My minimum this time, right? So instead of looking for my maximum and seeing how far it moved off, if I'm going to draw the negative cos graph, I'm going to look how far my minimum is moved. Okay? So my minimum, oh, look at this one. How far is this one off the y-axis? Trick question. It's not off the y-axis, is it? Is there any horizontal shift? Phase shift? Nope. This one's done. I don't have to add anything to it. My minimum's on the y-axis. It didn't horizontally shift it off. Negative cos for this one. I'm going to look for my closest minimum. This one is 45, but to the left. So I'm going to go x plus 45 degrees. This one, I'm going to look for my closest minimum. Where is it? My minimum was where? On the y-axis, isn't it? So this one's done. Do I need that excessive amount of brackets, or could I just write 2x? Yeah. Remember, what's cool about these is you can actually set your window to the same window as this and type them in, and they should match, right, if you didn't screw up your equation. This one I look for my closest minimum, and it's at negative pi over 2. So I'm going to go plus pi over 2 because I have to move it to the left. So to find your C value for positive coses, I look for the closest max, right? My C values for negative closest, I look for the closest min. Do we agree? Does that make sense? So C values for my max, I look for my positive closest, or I look for my closest max. Negative closest, I look for my closest min. This is why I made you do the intersections. It's for sine graphs. So I'm going to show you. So if I look at a plain old sine x graph, and I draw its midline is going to be at 0, because this would be plus 0 at the back, right? So its midline is 0. If I press graph, what's on the y-axis right now? The intersection between the midline and the graph, correct? Which I made you bold in all little yellows all the way along, right? But let's look at this. This one's a positive slope, isn't it? Positive slope intersection. What's going to happen when I do a negative sine x? Put down marker. So it's still the intersection, but now what is it? The negative slope, right? So we're going to go back to all of our bolded yellows. All those bolded yellows are C values. That's what they are. All the bolded yellows are C values. So if I want to do a sine graph, I want to do a sine equation, I need to draw my midline and find those intersections that are closest to my y, because those are my C values. Okay, so we're going to go back. I'm going to look here. Okay, these are C values. So I'm either going to use negative 45, I'm going to either go 45 to the left or 45 to the right, because these are my C values for my sine. I just need to figure out which the heck one goes with positive sign and which heck one goes with negative sign. I'm going to use yellow again. This one is a negative slope, and this one is a positive slope. So then one to the left goes with which negative sign or positive sign? Negative sign. So I'm going to go, I need to go 45 to the left. So I'm going to add 45 degrees. Well, that does it right very well, but I don't know. And then this one is to the right, 45. So I'm going to subtract 45 degrees. So that's why I did the intersections. Do you see why I did them? So if I go here, this one's a positive slope, this one's a negative, and so is this one a negative. So the positive slope intersection is actually on the y-axis. So which equation is done? The positive slope intercept is on the y-axis. So which one is done and has none? The positive sign, right? It's done. It has no horizontal phase shift because it's right on the y-axis. And the negative sign, I could either go 90 to the right or 90 to the left. It doesn't matter because they're equidistant. So they could give either answer. So it's 90 to the left I'm going to do. So I'm going to go plus 90 degrees. What they could do is they could say C has to be less than 0 or C has to be greater than 0 and force you to one way. For this one, my C's are either going to be pi over 4 to the right or pi over 4 to the left. Why? Because there's 4 ticks to pi. So I know this is pi over 4, this is 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. So this one has a negative slope. So the negative sign is going to be pi over 4 to the left. So I'm going to add pi over 4. And then this one has a positive slope. So it's a positive sign, and it's pi over 4 to the right, so I'm going to go minus pi over 4. That's just terrible to me. Then I have these two options. I have pi over 2 to the right is one option, and then if this is 2 to pi, this would be pi over 2, 2 pi over 2, this is going to be 3 pi over 2, but negative. So this one has a negative slope, so that's my negative sign 1. This has a positive slope, so it's my positive sign 1. So my positive sign 1 is pi over 2 to the right. So I'm going to go minus pi over 2. My negative sign 1 is 3 pi over 2 to the left, so I'm going to go plus 3 pi over 2. So if you don't draw your midline and intersection, C is really hard to find for sine. So I always just draw my midline right away, and my closest intersections at least have a fighting chance of getting my C. And cos is the closest max, and negative cos is the closest min. The homework for this is page 253. Number 15 and 16. 15, you have to do it for sine graphs. 16, you have to do 3 graphs for cos graphs. So you don't have to do all 4 for each of these. For 15, you have to do 3 graphs where you do positive sine and negative sine. And for 16, you have to do 3 graphs where you have to do positive cos and negative cos. So you're producing 2 graphs for each. 2 equations, not 2 graphs. Okay, so it's 15 and 16.